three substances, I get, so first I have a benzene ring with something bond O here and the bond H. And then the first step, let me just draw the first step here. The first step is I'm adding a cyclic group here, NH, and then I have H3O3 as the catalyst. And the second is I'm going to add some sort of bromine group. That's cool. So what it's going to do is, again, for the sake of time, I'm going to look at the solution, just verify it for you. I have a benzene group with the OH, so it's going to create it's going to add towards this carbon bond here. So I have 1, 2. So I have so it's going to add to this this oxygen group here, right? So that's good. So let me just redraw this for you. I guess I'll draw it vertically. I feel like I have more space vertically than horizontally. So the first step is, again, this this ringed type group, H3O plus. So it's going to form this type of compound here. Double bond here. This is an N, and then the ring. I'm running out of space, but you get the point here. The ring. This is the low ring. Sorry. This is your H. That's good. Basically, what it's doing is, again, I'm substituting my the carbonyl here with this the ringed nitrogen group here. And the reason why is that, again, this here is partial. This here is a partial negative here. Negative charge here. This one is a partial positive here. And the nitrogen group, again, it's a very electron. It's very electronegative here. So what it's going to do, it's going to bam, attack this double bond here. This is going to get kicked out. So therefore I get this kind of ring structure like so. And then I can catalyze, I can use acid, the acid workout to help provide the hydrogen for this in this compound here. And the second part is I'm adding methylbenzene, or sorry, bromobenzene. So some sort of bromo group bonded to Br. And then what it's going to do is going to bond to the double bond here. So again, I have this this negatively charged this here is, again, electron rich, and again this here is it's pulling this is pulling my negative charge here, and this here would be positively charged here, right? So basically what's going to happen is this electron rich group is going to come towards this and then kick out the bromine group here. So therefore I link my carbon bonds, right? So I have, again, this is my reaction here, the benzene. I have something like this, and it's going to break the double bond. I still have my ring here. So let me ring here, and this is still bond H. But then I have, again, this is now, it creates a double bond here because it's going to shift, this double bond is going to shift up. So I have, this is double bond here. This is a let me do this in blue. This is a positively charged thing. And then I also have, this here is going to connect to my, let me just verify this. 1, 2, hold up. Let me just, is there a, yeah, that's fine. Sorry, so this is going to connect, sorry, 1, 2, 3. Oh, it's going to, there's actually, this is a methyl shift, sorry. So I forgot to include my methyl shift here. So because I have a, this is not just a CH3Br, sorry. There's a methyl as well. So this is it's that. So I have, again, it's going to attack actually over here, and then Br is going to get kicked out. So this arrow doesn't exist, actually. It's actually attacking this guy here, and then Br gets kicked out. So I am adding a methyl group here, and it's going to shift my carbons here. So this here is going to go, this here is 1, 2, and 3. This is here is H. Or let me draw it like how they did here. Sorry, this is Br. So this here, I have, this is a benzene group. And I have 1, 2, and then this is, it's adding my benzene group, right? This is the addition of the benzene group here. And then I get, this here is the methyl shift, right? So again, my double bond was going to be 1, 2, 3. It was supposed to be like this, and then bond H or bond N, and then this is going to be, this here was going to be, this is double bond, and this here is bond H, and then it was supposed to do something like this, bond end, like so. But then what I can do here is I can actually shift, this negative, this double bond here to make a kind of a positively charged nitrogen on this group. So I'm going to shift this double bond to make this here is positively charged, which means the acid workup is simply just going to, becomes a very, very, very weak, very, very good leaving group for the acid. This is the H3O plus to kind of take over. So again, this is the negatively charged of H3O plus is going to come. It's going to come like so, and kick this entire thing out to make my final product, which is simply this guy over here. So I have the benzene group, and then I have 1, 2, 3. This is another benzene group, and 1, and this is the aldehyde, like so. So again, this here is a very, very actually complex reaction. So let me just break this down real quick before I end this video. Again, I have this here is, again, I have this negatively charged nitrogen. It's a very, very good nucleophile. It's going to come attack this this aldehyde group here, and then it's going to form the nitrogen group bonding group here. And what it's going to do is I have the double bond is being created because I have a methyl shift in, or this is a hydride shift, not a methyl shift, a hydride shift towards this guy here. So it makes the double bond. Afterwards, it's going to, this double bond is it's electron filled. What it's going to do is it's going to attack this positively charged bromine, or positive, it's going to attack this negative positive charged dipole carbon here, and then it's going to create this linkage here. Methyl shifts so that my nitrogen has the positive charge, which makes it a good leaving group for acid to become a nucleophile for it to attach and make the aldehyde here. So